Hello everyone, welcome to In 5 Minutes. So in this video we are going to see what is higher order differential equation with constant coefficients. So any equation of this form, so this is our higher order differential equation. So in our previous video we saw the concepts and problem of first order differential equation. So what are the first order differential equation? First order differential equation is nothing but having the term dy by dx or dx by dy, where the power of derivative is always 1. So this is the first order differential equation. But in this, as you can see here, the power of derivative is 1, then it is square, then it will be cubed, and so on till derivative of n. So this is the higher order differential equation. But what is the constant coefficients? Each derivative term has coefficients. Okay. So the coefficients a0, a1, a2, up to an minus 1 and an all are constants. So therefore this type of equation where we have the higher order differential equation and the coefficients are constant, then that equation is called as higher order differential equation, and which is equal to some function of x. Okay, so now in this equation I substitute d equal to d by x, then d square will be d square upon dx square, d cube will be d cube upon dx cube, and d raised to n will be d raised to n upon dx raised to n. So in this equation I am going to substitute this. So d raised to n upon dx raised to n we can substitute as d raised to n into y. Okay, and a raised to n is as it is. Similarly, a raised to n minus 1 will be here, and d raised to n minus 1 into y, and so on. Here will be d square y by dx square will be d square into y plus a1d into y plus a0 into y equal to x. From all these terms, if I take this y common, then I will get equation something like this: y equal to x. If you see this equation is nothing but the equation of polynomial. We know that we used to represent polynomial always in terms of x, that is x raised to n plus x raised to n minus 1, a0, a1, and so on. So similarly, this is the polynomial in d. So we represent this whole term as some function of d. So our equation becomes f of d. So instead of this bracket, we are writing f of d into y. So into y equal to x. So this is the general representation of our higher order differential equation with constant coefficient. So whenever we are given such type of problem, we always have to find the solution of this problem. And the solution of this type of problem is given by y equal to yc plus yp. What is yc and yp? Yc is complementary function. So the solution contains two parts. One is complementary function and another is particular integral. So whenever we are given the higher order differential equation with constant coefficients, the solution will have two parts. One will be the complementary function and another will be the particular integral. The complementary function will be same no matter what. The method to solve the complementary function will remain same for any type of higher order differential equation with constant coefficient. The particular integral will change for a different type. So we have type 1, type 2, type 3, type 4. So for each type, how to solve the complementary function will remain the same, but how to find the particular integral will differ in each type. So first we will see how we can find the complementary function. So for that complementary function, we will consider only fd.